Okay, for day 6 of 21st century geometry in chapter 11, we're going to recap and practice all the different angles we've studied in this chapter. Now, the first angle that we actually worked with was a central angle. And remember, a central angle had its vertex right at the center of the circle, and it was equal to the arc. The second angle that we worked with was called an inscribed angle. An inscribed angle is also sometimes just called an in angle. An inscribed angle is sometimes called an on angle. On angle, because it's on the circle, and it was equal to half of the arc. And then we had a couple of them that were more complicated. So let's talk about those complicated ones again. So this one was an angle that was formed by two chords. An angle that was formed by two chords is called an inside angle. The inside angle had its vertex on the inside, and it was equal to half the sum of the arcs. Sum means we're going to add. If you look at it, it kind of looks like an addition sign. And then the last one that we talked about in section 5, day 5 that we just finished up, that was the angles on the outside. See how these angles are all on the outside? And the angles on the outside, or outside angles, are equal to half the difference of the arcs. Difference, of course, means to subtract. So we're going to look at examples of all of these. And first we're going to figure out what kind of angle it is. So here's our first example. This one's a central angle. Central angles are equal to the arc. Hey, these are the easiest ones. So x would be 37 degrees. Not bad at all. This next problem, still a central angle. It's equal to the arc. So if the angle is 110 degrees, hey, then x is 110 degrees. Central angles, no problem at all. Here we have inscribed angles. And these were sometimes called on angles. Are equal to half of their arc. So the x will be equal to half of 110. So x would be equal to 55. In the next one, we once again have an on angle. It's equal to half of the arc. This time they gave us the angle, 65 degrees, would equal half of x. Hey, we've seen this multiple times. We know the drill. We know we're going to multiply both sides by 2. 2 times 65, 130. And over here, we just have x. Still not a big deal at all. Got those down. Number 5. Now, number 5 is an outside angle. This was the last one we studied. They're equal to half the difference of the arcs. Now, the two arcs would be this arc right here and this arc out here. And you know what? That arc is what we're looking for. I'm going to call that x. So the angle is the 35, 1/2. The big arc, that's the x. And then the small arc is the 46. And once we have it set up, then it's just an algebra problem. 2 times 35 is 70. We end up with x minus 46. We add 46 on both sides. 116. So the measure of arc Q to U, 116 degrees. Hey, just like we did in the previous day. The next one. Here we have an inside angle. Inside angles are equal to half the sum of the arcs. And let's see, we're looking for angle UTV. So we're looking for this angle up here. The two arcs associated with it would be the 204 and the 50. So I guess we're actually just ready to set it up. X equals okay, second here. One half times 204 plus 50. X equals 1/2. 254. X equals 127. So the measure of angle UTV is 127 degrees. The next one. Well, first let's classify it. Looks like we're dealing with an outside angle. So it will be equal to half the difference of the arcs. The arcs that go with the angle are this one and this one out here. We have the angle. The arc we're looking for is this one. So I think it's ready to set up. 56 equals half the big arc minus the small arc. Multiply by 2 on both sides. 2 times 56, 112. 160 minus x, subtract 160. Negative 48. Divide by negative 1. So the measure of arc M to K, 48 degrees. Hey, that's just like one we've done before. The next one. Angle YWX. YWX. Well, angle YWX is actually this one up here. But before we can find that one, I think we'll find this one first. And the reason I think we should find that one first is we know the arcs that go with angle Y. Right there. So we're dealing with an inside angle. It will be equal to half the sum of the arcs. So Y will be equal to half of 43 plus 81. Y will be equal to 62. And then to find the x, we're going to use a linear pair. X plus 62 equals 180. So x will equal 118. So the measure of angle YWX will be 118 degrees. Got to make sure we know which angle we're looking for. Okay, once again, looking for an angle. We're looking for angle ABC. That's this angle out here. Looks like it's an outside angle. It'll be equal to half the difference of the arcs. Well, the arcs that go with it are this arc. Hey, they gave us that one. And then this arc out here. Okay, we're going to have to find that one first. Find arc Y first. Well, we'll do that by taking the full circle, and we'll subtract 88, and we'll subtract 62. 210. And then we can just set it up. So the x, the outside angle, is going to be half the big arc minus the small arc. So the x will be 74. So the measure of angle ABC, 74 degrees. The next one. Okay, now this next one asks us for angle C to B to D. This one right here. CBD. Now, that's a central angle. But I think we can find it by using a linear pair. I know that x plus 140 is going to equal 180. So x will equal 40 degrees. Measure of angle CBD, 40 degrees. So that one was pretty easy. We could have done that even before this chapter. Looks like this time we're looking for an arc. And the arc we're looking for is T to S. I'm going to call that one my X. We have an inside angle. So that's half the sum of the arcs. The inside angle is the 91. So 91 equals half. And the sum of the arcs would be x plus 57. Hey, it's just algebra from here. 2 times 91. 2 times 1/2. 2 times 91, 182, equals x plus 57. Subtract the 57. X equals 125. So the measure of arc TS, 125. Okay, things are just hopping right along. The next one, measure of arc M to K. M to K is really this one out here. So that's the one we're trying to find. But once again, I think we're going to find this arc first. Now, we have an on angle That will be equal to half of the arc. So the angle is 51 degrees, and that's half of y. We can multiply both sides by 2. So I get 102 degrees equals y. And now we'll find x. X will equal the full circle minus the 130 minus the 102. So x will equal 128. So the measure of arc M to K is 128 degrees. Sometimes we can't directly find what we want. We have to find something else first. That's called an intermediate answer, and then use that to get what we were looking for. So how about on this one? Now, this one, we have an inscribed triangle. So it's going to be a right triangle. I know that this angle, x, is 90 degrees. But I'm looking for angle WYX. WYX. So I'm actually looking for, I don't want to use x this time because we already have x. So I'm looking for this one over here. I'm going to call that little a. I think we can find this arc right out here. And to find that, I'll take 180 and subtract 106. I find out that that arc is 74 degrees. And then it's an on angle equals half of the arc. So the A would equal half of 74. So the A would be 37. So the measure of angle WYX will equal 37 degrees. Next problem. Okay, looking for arc SW. SW would be this one right out here. I can use x this time, so I'm going to call that x. We have this arc, and it looks like we're dealing with an outside angle. So that's going to be half the difference of the arcs. This is the big arc. So I have 75 degrees equals half, and then x, take that back. The angle is actually 40 degrees. The small arc was the 75. We'll multiply by 2. 80 equals x minus 75. Add 75, we get 155. So the measure of arc SW, 155. Angle DEC. DEC would be this angle right here. That's an inside angle. And that will equal half the sum of the arcs. So x will equal half 50 plus 210. These are the two arcs. So x will equal 130. The measure of angle DEC will equal 130 degrees. Looking for an arc again. Q to U, so the arc we're looking for, this arc, I'm going to call it X. We have this arc. We have this angle. Looks like we have an outside angle, and that will equal half the difference of the arcs. So 35 degrees will equal 1/2 big arc minus small arc. Multiply by 2 on both sides. 70 equals x minus 46. We add 46. 116 is equal to our x. So the measure of arc QU, 116. It appears once again we're looking for an arc. We're looking for the arc from M to K. It's an outside angle. It will equal half the difference of the arcs. So 56 degrees will equal half big arc minus small arc. Multiply by 2 on both sides. 112 equals 160 minus x. Subtract 160. Negative 48 equals negative x. Divide by negative 1. X equals 48. The measure of arc M to K equals 48. Now, if I'm going through these too quickly, please understand that you can go back, go through it again and again and again if you'd like to. So let's take a look at this one. Angle DEG. Well, angle DEG would be this angle out here. And that's actually an on angle. So that's going to be equal to half of the arc. So the x is going to be equal to half of this arc out here. So it will be equal to 154. The measure of angle DEG will equal 154 degrees. Okay, looking for an arc. The arc from E to F. This is the arc we're looking for. I'm going to call that X. This is one where, again, I think we're going to find a different piece first. So let's find arc Y first. We have an outside angle, and that's going to equal half the difference of the arcs. So 77 degrees equals half 191 minus x, multiplying by 2 on both sides. 77 times 2, 154 equals 191 minus x, subtract 191. Negative 36 equals negative x divided by negative 1. Oh, take that back. That's actually the y that we're solving for. So those are y's in there. So the y would be 36. And now let's find x. So to find x, we'll take the full circle, 360, we'll subtract the 191, and we'll subtract the 36. So the x is 133. The measure of that arc then, EF, is equal to 133. Sorry about that, I had the wrong letter in there for a while. Number 20, just a couple more problems to go through. We're looking for angle DBC. Well, DBC is actually this angle over here. But I think we need to find the arc that's associated with it. So we need to find arc Y first. And we'll do that by taking a full circle and subtracting the 192. 360 minus 192, I get 168. So this is 168. And now we have ourselves an on angle, so that's going to be equal to half of the arc. So the x will equal half of 168. 84. So the measure of angle D to B to C will be 84 degrees. One last example. Number 21, we're looking for the arc x to y. Well, the arc x to y is this arc right here. That's the one that we want. I don't want to use x, so I'm going to call that A. But before we can find that, I think we need to find the angle. And we'll find that angle by using a linear pair. That angle will equal 180 minus 151. So that angle will be equal to 29 degrees. And then what we have there is we have an on angle. And that will be equal to half of the arc. So the 29 degrees will equal half of A. We'll multiply by 2. 2 times 29, we get 58 degrees equals A. So the measure of arc x to y will be 58 degrees. Okay, that was quite a few practice problems, but we mixed in all the different types. And again, if you want to